last ice age, around 20,000 years ago. Next one. The Bothnian Bay was deglaciated around 10,000 years ago, and on the right-hand side you can see the deglaciation map here, which shows this line that around 10,000 years ago the Bothnian Bay was free of ice sheet. And we can say that the Bothnian Bay is geologically very young. It's the youngest part of the Baltic Sea and probably one of the youngest oceans or sea areas in the whole world. Hudson Bay is a bit younger, but I think so the Bothnian Bay might be in the second place. Next one. So the melting of ice sheets led to ocean sea level rise around 10,000 years ago and a bit later on, and that also triggered land uplift, which is still going on in this area, and you can see in the map it's up to 1 centimeter per year in these regions. But if we take account of the current sea level rise, the relative sea level rise or relative to sea level rise is around 7 to 9 millimeters at this moment per year. Next one. Just after deglaciation, the Bothnian Bay was around or up to 300 meters deeper than today. Here you can see the shore displacement curve from the northern tip of the Bothnian Bay. We can see ages here from 11,000 years back to present day, and the elevation above the present sea level. And you can see that around 9,000 years ago, the ancient shoreline was around 200 meters above the present sea level. And today, the new land is born or rising from the sea around 700 hectares per year. That estimate is for the whole Gulf of Bothnia. And in the red color, you can see the uplifted areas over the past 8,000 years and submerged landscapes or in this southern part of the Baltic Sea. Next one. And over the past 8,000 years, the Baltic Sea area has decreased around 30%, and the water volume has decreased around 50%. That's quite a lot. And in the Bothnian Bay, the changes have been relatively higher due to the higher uplift. And over these thousands of years, the large areas of seabed in the Bothnian Bay have been subjected to potential erosion, mainly wave erosion, and this is particularly the case in the Finnish coast, which is very shallow. In this map, you can see the timeline, duration, how many years or thousands of years the seabed has been exposed to the waves, and you can see, like in the Finnish part of the Bothnian Bay, it's more than 5,000 years. So there's a lot of erosion going on. It has been going on, and it's still going on. Next one. Salinity, sea surface salinity has changed a lot around 10,000 years ago when we had the Angelus Lake here. So it was a large freshwater lake, and since around 8,000 years ago we have had the brackish water conditions. And the next slide, a bit more detail. Here's one study, paleo-salinity reconstructions based on strontium isotopes, isotope analysis from mollusk cells, mainly Macoma baltica. It shows or indicates that maximum surface salinity has been around 10, 11 ppg around 3,000 years ago. So here we have salinities, present day salinity here, a timeline from 8,000 years back to today. And you can see that this area was much more saline during those days. And quite interestingly, if you look the sediment cores, you can also put the next one. If you look the sediment cores, there's one example from the northern tip of Bothnian Sea long sediment core, which shows, here are the ages again, 7,000 years ago towards present day. We can see here we have foraminiferas living that time in the sea, Elphidium, and you can see that we have those guys in the seawater still around 2,000 years ago. That means that last inflows of large saline water pulses from the main or proper Nordic Baltic proper came into this basin. And also primary production and sedimentation of organic matter was much higher during earlier phases, around 4,000 or 5,000 years ago, and deep basins were also anoxic. So to conclude, Bothnian Bay has experienced significant changes, as you saw from those earlier slides, during the past thousands of years. And next one. And ongoing land uplift modifies not just the coast, but also the seabed slowly but steadily, and seabed is under a constant change. So now we move under the water, see what proper results, and Gustav will continue.
Thanks. So at the start of the SEAmBOTH-project, this is roughly what our maps look like. And on the right-hand side there, you see lots of colors, and it looks like we have a pretty good map of the northern Bothnian Bay. But reality is that these maps were made from best knowledge and drawn by people. And up on the upper left there, you see where we actually had reasonable survey data, and it was very patchy. And then in the bottom there, we also had some compiled bathymetry that was on this zoom level looking pretty good. But when you look closer, it's different. Sorry.
Yeah, next time.
So in the SEAmBOTH-project, we had some priority areas that we wanted to look closer at. So in these areas, we went and did surveys and got all the information needed to make maps. Some of them are already in this EMONet portal, and on the Swedish side, we're still waiting for final permissions and so on. So these pilot areas, or these smaller, well, quite small, they're actually quite large areas. They are a way to really scrub away all this bad data and see what's down there, and have an idea also what the larger area could look like. And we've been there, we used the ships and collected it's called multi-beam data, where you have a full topography of the seafloor. We also look down in the sediments and get cores, so we can see deeper what the stratification in the sediment look like. And we also have cameras and go down and look at what's actually on the seafloor, and we collect mainly geological information, but also biological information since it's in there. It's easy to get fooled by the size in the northern Bothnian Bay. We learned that quickly. But actually, our sort of pilot area was about 200 square kilometers. And the neighboring one there on the beach side was similar size. And this is all the track lines from the boat going forth and back. So there's been quite a few hours with the ships in this very tricky exposed area as well. And we almost hit a shoal once with our big ocean surveyor 40-meter catamaran, because it said 15 meters in the chart, and it was about 4 or 5 meters in reality in the offshore area. So, which also was areas we couldn't fully survey. And this is a view of the high-resolution data that we have. This is about 0.5 meter terrain model, and when you have this kind of resolution, you see things already directly in the images. You can see processes like how the waves and currents have formed the seabed. You see features. And then we put down the camera on these selected features, which makes us be able to target very small areas with like special habitats. For example, there on the third
was it just this one here?
So here, for example, you see these kind of hard compacted clay areas, and they have formed these very specific small reefs that we found in a few locations. But we really need this high-resolution data to find them. Okay, we can move on.
Talk to the laptop.
Are we using the microphone from here? Okay.
Okay. So on these kind of surveys, we also notice what's in the videos, and we get data on fish and things like this as well. And one thing that's striking is that we find life almost everywhere. So even these dark areas in this, we found lots of shrimp and small fish, and some perch and things like that. So I don't know, quickly on the environmental, very quickly.
So then, of course, we did some sediment sampling, working on how the human impact can be seen in the seabed sediments, and this is just one example showing from short sediment cores, like that one. Right-hand side, you can see the sediment core 50 centimeters long. Down here at the top here, these are lead measurements from several cores taken from the outside of the chemical near river, also here, and some samples here. You nicely, or not so nicely, but you can see increased lead values early 60s, 70s. But nice thing is that when you move towards present day, values are decreasing. So that's a good sign. Next one, please. And then these are one of our main products, seabed substrate maps. Here you have a color scale, dark colors, mainly hard substrate like chill, and blue colors are soft sediments, mud and clays. Here's our large area, Swedish side, Finnish side. This is our combined area. We did studies jointly here, and the idea was to harmonize our methods and data. So but this data is already available in the Finnish side, but we're still waiting for permissions from the Swedish side, but we will get that. So this is quite large and nice area. Main issue is there. It's very heterogeneous, as you can see from the maps.
Okay, so here's a very complicated slide, but quickly, we also been working on modeling and see what we can get out of the data with some of the high-resolution modeling methods that we have been developing. I will not talk so much about it, but the idea is that from this high-resolution data, we can create models, but we can also use expert interpretation to strengthen them. And then we do that for the geology, and then that helps us to make also, if we want biological models as well. But here we're focusing on the deep, so it's not so much in the biology for our side. And here you can see one of the zoomed in areas. It's a geological interpretation made by hand. Very nice map. And then on the middle one, you have a model of what's on the surface. So here we can get actually percent coverages of different sediment types. So very detailed 5-meter resolution. And then on the right, that's an example of a freshwater hydroid model as well. So together they form the seabed habitat. This is leading into my little second talk today, but we also used the data collected by all partners in SEAmBOTH and updated our very new Baltic scale model for substrates. This is not published yet, but this is a preview of the draft. And here you can see that now we have much more detailed knowledge of what's in the larger area. But still these models have limits on what data we put into them. And when we zoom in on the right there, you see the difference between the high resolution model that we make from the SEAmBOTH pilot area data on the bottom right, and what the model, the predicted model with coarser data look like. So to really capture what's down there, you need good data, even though we can make very useful models for the larger patterns. But this is very important to know when you're using these model and pretty maps over large areas. And then finally, you can see now a little bit the difference in the amount of patterns we find from this original picture to what we start to see now in the larger models as well. So quite new patterns where we have the soft bottoms and the hard bottoms and so on. And that's all for